Hi, it's Alex, and today I'm going to be walking you guys through my process for problem 4 from lesson 18. So problem 4 gives us a PDE to describe the vibration of a string as well as an initial displacement, and asks us to describe the solution in the xt plane. So first, looking at our PDE, we can see that it is our standard equation, and that is u sub tt is equal to v squared u sub xx. And given that our equation here is just u sub tt is equal to u sub xx, we know that our c squared value is going to be equal to 1. So this will be important when we start looking at our characteristic wave equations, when we start transferring our initial condition from the xu plane into the xt plane. So looking at our graph for our initial displacement, we can see that it is discontinuous and that it alternates from a height of 0 to 1. So these displacements themselves can be broken up into two waves of equal height moving in opposite directions. So we will have this purple wave of height 1/2 moving to the left, and this blue wave of height 1/2 moving to the right. Also, as you can see on the bottom, I highlighted the areas where the displacement is 1 in yellow and the displacement is 0 in blue, which will be important when we start looking at our xt plane. So in this problem, it is a fully infinite string. So as the initial displacement continues infinitely, we will then also have this infinite number of critical points in which the initial displacement is changing from 0 to 1 or from 1 to 0. So using these critical points or initial displacements, we can find the left and right moving waves for each point. So these lines are given by x minus ct is equal to that critical point, and x plus ct is equal to the critical point. So as we can see here, we have our x plus t is equal to -3, and so this will be our left moving wave, and then we have our x minus t is equal to -3, and that is our right moving wave. So picking points for various times, we can backtrack along our lines to see where they fall in the initial displacement. And so looking at these various times, here we can trace it back and we see that it lands in an area of 1, and on the other side it also lands in an area of 1. So we'll know that if I had drawn another line to make this a bounded region, that this area would then be 1. Here we can do the same thing and see that it goes back to an area originating from a value of 0 and a value of 1, which gives us 1/2. And then here it comes both from a displacement of 0, so we know that this is 0. Doing this for different and many values of time, we can get this displacement, and we can see this nice pattern of it alternating between heights of 1 and 0, and then areas in which the waves are stacked on top of each other here, and then when they're not stacked on top of each other, so that we get this even height of 1/2 throughout. So looking at some time 1, we can see that this displacement moves and changes from 1 to this 1/2, and we still have these areas of 0. So the waves at points are still stacked on top of each other, but they are moving away from each other. So at this point, we can see that the areas of 0 and 1 height are shrinking, while the string is beginning to move towards this area of a uniform 1/2. So transferring these values from the xt plane into the xu plane, we can get something that looks pretty similar to this. As you can see, we have our waves coming a little unstacked from each other and beginning to move in opposite directions. Looking at it for a supposed time 2 in which this hinted at moment of them all being unstacked with a uniform height of 1/2, we can see that the waves have come unstacked and we do have this uniform height of 1/2. So for the following slices, I looked at similar ideas for heights for times 1 and 2. And so for time 3, we are able to see the same pattern as time 1. We have these various heights of 1/2 and then 0 back to 1/2 and then to 1, and that just continues throughout. But looking at our two graphs from our time 1 and our time 3, we can see that where it's 1, a height of 1 in our time 3, that it's a height of 0 in our time 1. And so that is clearly showing how these waves are shifting and stacking and unstacking as time changes. So moving on to a fourth time, this once again is very similar to a previously shown wave, but this time it's similar to our initial displacement. So looking at our initial displacement, we can see here how the waves have moved and once again have been fully stacked so that we can get this nice height of 1. Time 5, and for the final time that I looked back at when the string did reach this uniform and constant height of 1/2 across the string. And so although our differences are not as pronounced and it does have no visible shifts in where it's a height of 1 or a height of 0, because it is this uniform height or displacement of 1/2 throughout the string, it does look exactly like my supposed time 2, except if we look at the areas that I colored to denote the moving waves, we can see that they have shifted to kind of show this change that is occurring as the waves move. So as we're seeing through the xt plane graph and the xu plane graphs, the displacement of the waves will be values of 0, 1/2, or 1 as the waves move past each other, stacking and unstacking. So this movement in the waves will follow similar patterns where the displacement of the wave occurs for all time in the future.